Is it possible to effectively initialize byte array with non-zero value? I need to have huge Boolean array. All values should be initialized as true. But created as above, it takes too much memory. So I decided to use byte array for that. Is it possible to initialize byte array with b\x01 as effectively as it is initialized by b\x00? I understand I could initialize byte array with zeros and inverse my logic. But I prefer not to do that if possible. Timeout.
Easy, use sequence multiplication. Same approach works for initializing with zeros, byte array, b\x00, *10**9, and it's generally preferred, since passing integers to the bytes constructor has been a source of confusion before. People sometimes think they can make a single element bytes with the value of the integer. You want to initialize the single element byte array first, then multiply, rather than multiplying the bytes and passing it to the byte array constructor, so you avoid doubling your peak memory requirements, and requiring reading from one huge array and writing to another, on top of the simple memset-like operation on a single array that any solution requires. In my local tests, byte array, b\x01, *10**9 runs exactly as fast as byte array, 10**9, both took ~164 ms per loop, versus 434 milliseconds for multiplying the bytes object, then passing it to byte array constructor.
Consider using numpy for this sort of thing. On my computer, np.ones, which initializes an array of all 1 values, with Boolean d-type, is just as fast as the bare byte array constructor. If you don't want to use third-party modules, another option with competitive performance is to create a one-element byte array and then expand that, instead of creating a large byte string and converting it to a byte array. Since my computer appears to be slower than yours, here is the performance of your original option for comparison. Cost in all cases is going to be dominated by allocating a decimal gigabyte of RAM and writing to every byte of it. fx is roughly twice as slow as the other 3 functions because it has to do this twice. A good rule of thumb for you to remember when working with code like this is, minimize the number of allocations. It may be worth dropping down to a lower-level language in which you can explicitly control allocation. If you don't know any such language already, I recommend Rust.
Are you using numpy? You could do returns. Also, you can easily convert back to bytes with an array.tobites, as in see this answer for more details.
If you want to support the channel, please consider subscribing.